The question we are solving now belongs to test series 4. It is of control system subject. In specific, it belongs to Nyquist plot. As per the question, the open loop transfer function of a unity negative feedback control system is given as g of s h of s is equal to k by s multiplied by 1 plus 0.1 s multiplied by 1 plus 0.05 s. And please note that this question is a common data question. As per the question, we need to find the value of k such that gain margin of the system is 20 dB. We know that gain margin GM can be given as 20 log 10 apps of 1 by G of j omega p h of j omega p. And we know that the omega p mentioned here is phase crossover frequency, and at phase crossover frequency, imaginary part of g of j omega multiplied by h of j omega is equal to 0. Now first let us find out g of j omega h of j omega, which can be written as k by j omega multiplied by 1 plus 0.1 j omega multiplied by 1 plus 0.05 j omega. So upon simplifying this, we see that this can be written as minus kj multiplied by 1 minus 0.1 j omega multiplied by 1 minus 0.05 j omega divided by omega multiplied by 1 plus 0.01 omega square multiplied by 1 plus 0.0025 omega square. So from this, upon equating the imaginary part to 0, we see that the phase crossover frequency omega p can be written as 10 root 2 radians per second. And upon substituting the same for gain margin, we see that Gm is equal to 20 log 10 of 1 by k divided by 10 root 2 multiplied by root 3 multiplied by root of 3 by 2. And this is equal to 20 dB as per the given data. And upon simplifying this, we see that the value of k that we get here is equal to the value of k that we get here doesn't correspond to any of the options given. So from this we see that the correct option representing the value of k is D, which says none of these.